Enrico Fermi, a brilliant physicist, was having lunch with colleagues in 1950. The conversation drifted to flying saucers, then to the vastness of the universe and the sheer number of stars. Suddenly, Fermi blurted out a simple, profound question that has echoed through the decades, still unanswered. But where is everybody? This question forms the heart of one of the greatest unsolved mysteries in science, a puzzle known as the Fermi Paradox. It's a contradiction that gnaws at our understanding of our place in the cosmos. We look up at a universe teeming with perhaps 2 trillion galaxies, each containing hundreds of billions of stars. Many of these stars, we now know, host planets, countless worlds, some potentially Earth-like, orbiting in conditions suitable for life. Statistically, it's difficult to imagine that our little blue planet is the only place where intelligent, technological civilizations have ever arisen. If life is common, and if even a small fraction of that life evolves intelligence and technology, then the universe should be buzzing with activity. Yet when we point our most powerful radio telescopes at the sky, when we listen with dedicated projects like SETI, the search for extraterrestrial intelligence, or more recently, Breakthrough Listen, we hear nothing. The universe is profoundly, bafflingly silent. Why? One significant reason for this profound silence might simply be the vast, mind-bending distances involved and the fundamental speed limit of the universe, the speed of light. Even if a civilization on a planet orbiting Proxima Centauri, our very nearest star system, were to send us a message today, it would take approximately 4.2 years just to reach us. If we then replied immediately, their original senders would receive our response over 8 years after their initial transmission. Think about how much our own technology, our culture, even our entire species, has changed in just 8 years. A civilization sending a signal might have advanced, migrated, or even vanished by the time any meaningful dialogue could begin across such cosmic gulfs. Beyond the immense travel times, signals themselves face an uphill battle across interstellar space. They weaken drastically, spreading out in all directions following an inverse square law. Imagine a light bulb. Its brightness diminishes dramatically as you step farther away, not in a straight line, but exponentially. That's how radio waves dissipate, making them incredibly faint after crossing light years. Adding to this challenge is cosmic interference, all the natural radio emissions from stars, vast nebulae, and even supermassive black holes. Detecting a faint, deliberate signal becomes like trying to hear a single whisper across a stadium during a loud rock concert. While humanity dreams of faster contact, with projects like Breakthrough Starshot aiming to send tiny light-speed probes to nearby stars, even that ambitious effort has faced restructuring and is not actively progressing toward launch right now in 2024. But even with these hurdles, it doesn't fully explain the silence from civilizations that could have had a billion-year head start on us. Surely, some would have developed ways to send powerful, persistent signals. Perhaps the reason for the silence isn't about communication, but about existence itself. This idea is known as the Great Filter. The Great Filter proposes that somewhere along the path from the emergence of simple life to an advanced, spacefaring civilization, there's an extremely difficult or even impossible step, a filter, that very few, if any, forms of life can pass. This filter could be in our past. Maybe the very origin of life from non-living matter, the spark of biology, is incredibly rare. Or perhaps the leap from single-celled organisms to complex, multicellular life is the monumental hurdle, on Earth, that took billions of years. But here's the unsettling thought. What if the Great Filter is still ahead of us? What if every technological civilization, upon reaching a certain level of advancement, inevitably succumbs to some self-inflicted catastrophe? This could be through global nuclear war, irreversible environmental collapse due to unchecked resource consumption, the unintended consequences of advanced artificial intelligence, or even bioengineered plagues. Or perhaps, as a civilization grows, it outstrips its home planet's resources, collapses into chaos, and never quite achieves interstellar travel before fading away. If this is the case, then humanity's future might be far more precarious than we realize, and the silence we hear from the stars isn't because no one is there, but because everyone who was there has passed through their own fatal filter. Another compelling possibility is that the very specific conditions that allowed complex, intelligent life to flourish on Earth are astonishingly rare throughout the universe. This is the rare Earth hypothesis. It suggests that the precise set of circumstances required for advanced life to evolve and thrive might be far more demanding and improbable than we generally assume. Consider our planet. It orbits in a very specific, stable Goldilocks zone around a sun-like star, not too hot to boil oceans, not too cold to freeze them solid. We also have a uniquely large moon that stabilizes Earth's axial tilt, leading to predictable seasons and preventing extreme climate swings that would make complex life impossible. Furthermore, our planet exhibits active plate tectonics, which is vital for long-term climate regulation by recycling carbon dioxide from the atmosphere back into the Earth's interior, and also for creating the varied topography necessary for biodiversity. And we're positioned in a relatively safe region of our galaxy, far from the chaotic, radiation-rich galactic core, where supernova explosions and other destructive cosmic events are more common. The rare Earth hypothesis argues that if you combine all these precise, interlocking factors, the right kind of star, the right planetary size and composition, the right orbit, the presence of a large stabilizing moon, active plate tectonics, a protective magnetic field, and a stable galactic neighborhood, the chances of all of them lining up perfectly in one place become astronomically small. However, this hypothesis also has its critics, who argue that our understanding of what constitutes habitable is still very limited and potentially biased by our own Earth-centric perspective. Life might simply find other ways or thrive under vastly different conditions we haven't yet imagined. What if civilizations are out there, perhaps even in abundance, but they're intentionally silent? This chilling idea is known as the dark forest hypothesis, a concept famously explored in the science fiction novel of the same name. Imagine the universe as a vast, dark forest full of unseen hunters. Any civilization that reveals itself by sending out a signal immediately becomes a target. In this terrifying scenario, showing your presence is an act of extreme danger because you can never truly know the intentions of others. A more technologically advanced civilization might view any newcomer not as a friend, but as a potential threat or a resource to be exploited, an unknown variable that could eventually pose a danger. Given the immense distances and time scales, direct communication might be impossible, but the threat of destruction by superior force could be enough to instill a universal policy of extreme caution and silence across all advanced species. Therefore, the safest strategy for any intelligent life, once it achieves technology capable of interstellar communication, is to remain hidden, to listen rather than to transmit, and to assume that anyone else who does make noise is either reckless or dangerous. If this hypothesis holds true, then the cosmic silence isn't a sign of absence, but a chilling testament to a universal imperative for self-preservation, where every civilization hides in the shadows, waiting. So the Fermi Paradox remains, a profound question hanging over us as we gaze at the stars. Is the universe truly empty of others, or are they simply too far away, too different, or too afraid to speak? Is there some insurmountable barrier that prevents intelligent life from reaching for the stars, or are we simply not listening in the right way or to the right things? We've explored some of the leading scientific explanations, each with its own compelling logic and significant uncertainties. What's clear is that the answer isn't simple, and we are still very much in the dark. The cosmic silence is not a sign of scientific failure, but rather an invitation, a profound challenge for humanity to continue to explore, to listen, and to ponder our unique place in a universe that still holds so many breathtaking, unsolved mysteries. If you're as fascinated by these cosmic puzzles as we are, consider subscribing to our channel for more explorations into the unknown.